All right, sports fans. So, welcome to week 5. And I think we're going to start with are just questions on the week 4 homework. So I'm going to dip into the forum, see what's laying out there. I've already covered sort of the fundamentals of power factor. I've shown the formula and all that good stuff. So I think we're ahead of the game for those of you who are into week 5. We'll dip into the week 4 forum. Here it is, 11 unread posts. Perfect. And let's just see if there's something. Okay, now this is close. This is good because I've got a problem too. Now, what I'd like to see in the future, team, is just a single, so it looks like Orem may have started a problem 1. What I'd like to see in the future is if Froelich comes in later, or no, it looks like Orem started a new problem 1. Looks like Warner started the first one. Okay, so Froelich should have just tapped into Warner's problem 1, and then Orem should have tapped into both of those, and then DeGray should have labeled his forum as a problem number. And the reason for that is so that we have just as many subtopics in the forum as there are questions, so that every question on a given problem is in the same spot. There we go. Okay. So guys, that's just a primer on how to use the forum once again. So let's just start with, let's just start here. Froelich's problem 2. Cool, max charge, good. Calculator isn't sure if we're just supposed to pick whether or average, use that value. Okay. This is a just defined place to start. So let's just take a look. Open with Froelich. Actually, let's go back and look at the problem statement for learning unit 4, problem 2. Use factor, some nice definitions there. Okay, problem 2. Actually, no, I take it back. Let's start with problem 1 because problem 2 hinges on problem 1. So let's just look at that guy. So I'm going to take this. I'm going to copy it. And so if I were just starting from scratch, come in here with a new spreadsheet. I would insert a text box. There's probably other ways to do this as well. Put in a text box. Boom. Okay. Pretty simple. So all I've done there. And if you want, I think there's a way to format the shape. And we can fill it with solid fill and make it white so that it's easier to read. So, problem 1, we make this box a little narrower. Get everything on the same page here. Okay, so calculate the annual operating cost and use factor for a 3-phase motor. Use the medium general service G2 rate, secondary service. Do not include the reactive charge. We'll get to that next week. Calculate the annual cost for this motor considering service fee, energy, and demand cost. So there's 3 fees there, like what it costs to have it plugged in, how much energy used, and the demand. So you've got a 100 horsepower motor. It operates Monday through Friday, 10 hours a day. We're looking at 87, 60 hours per year. We are going to use it while during the demand period, so peak energy use. We're going to read the meter monthly, and we're going to assume that it's running at 70% load factor. So that's the problem as stated. Let me back out and take a look at some possible solutions. Okay, so let me take you through a solution. So what we're looking at again, and let me see if I go back to this guy. I can take this, I can do copy, I can do alt tab, I can come in here, I can do paste. Let's see if I can make this even more compact. Okay, so what we're looking for is the annual operating cost. And if we just sort of skip ahead right here, these are kind of the numbers that came out. So somewhere between 15,000 and 13,000. Now in this particular case, we've got a service fee of $6.94. So if we look at L9, this is the monthly service fee of $57.85 that came out of the problem, times 12 is your $6.94. So that's easy. There are a couple different demands. We'll get into what that is. Let's go back and look at the annual energy. We'll just work our way backwards in this. So energy from here, we're looking at what we're calling the original energy times L10, and L10 is just the energy rate. So somewhere here we've calculated what we're just going to call original energy, and that is at 135,772 kilowatt hours per year. Where does that come from?
Yeah, that's what I want to know.
Okay, so what we're looking for is the hours per year times the power.
Where did you get the original power?
Okay, so let's figure out where original power comes from.
'Cause
Fantastic question. Okay, so the original power, we're looking at the M14, which is the nameplate horsepower. So it's 100 horsepower, and it's only running at 70%. It's only running at 70%. So it's 100 horsepower running at 70%. And again, this is horsepower, and we need to convert that into kilowatts. So to get from a horsepower to kilowatt, we multiply by 0.746. And right now we're assuming that it's 100% efficiency. So the M16 doesn't even come into play. We could get rid of M16 and we still get the same exact number. So what we're looking at, I'll just undo that. So what we're looking at is the assumption that we're making is that it's only operating at 70%, and that's written right here. Assume the operating position is a 70% load factor. So if it were operating at 100 horsepower for, what did we say, Monday through Friday, 10 hours per day, 50 hours per week, there's your 50. We've just taken it out to 52 weeks per year. And then the hours per year is just hours per day times weeks per year. So that's where this original power comes from. So it's the load factor. There's the power in kilowatts. Here is the original energy in kilowatt hours, because we've multiplied hours per year times kilowatts, to get kilowatt hours per year. Okay, so that's where that comes from. Now, let's check out the annual demand. So to get the annual demand, we're looking at the high power, which is when it's running at greater capacity. And again, this is in kilowatts, so if it's running at 100 horsepower, that's approximately 70 kilowatts. So we're looking at the high power times L11, which is the demand rate. So that means when it is running at full tilt, it's going to they're going to charge you $7.25 per kilowatt. They're not charging you for energy, they're charging you for power. So the demand rate is $7.25 per kilowatt. And the high power give me a quick second. Okay, so there's a little bit of contention over this demand cost, and the point of contention, there's an old solution here by Fraser where he's saying that we're running at 70 kilowatts, and I just don't know where that number is coming from. I think it would be just fine if we said, hey, we're going to pay a premium, and that premium is 52. You're still going to get a number on the order of $4,000, because this is the power at which the thing is running. So if you're running at 52 kilowatts, which is 70% of 100 horsepower, we're going to take that guy and multiply it by the monthly demand rate times 12 to get the answer. So we're looking for an answer in the order of this right here. So the point is, every month where you go over at least once, you're going to pay that fee multiplied by the amount of power you are consuming.
A lot for a year.
It is a lot. Well, you're what are you doing though? You're fixing cars or something. You're making a lot of money too. So, okay, let's just let that guy sit. I think we understand. So to recap, the service fee is straightforward. The energy cost is pretty straightforward. It's this demand cost that's a little wonky, but we realize that we're going to pay $7 per kilowatt times the number of kilowatts per month, and there's your 12.
For 12 months.
Yeah, so we're looking at the annual. So if it was just 1 month, you're looking at $388 a month. But since we're doing the full year, times 12, there's your answer. I think what, I think what this guy was, I see what's going on. This was just another, that's actually pretty good. This column was just another, for instance, we could just say that this was like a peak state. So if we go back and say, hey, yeah, we actually cranked up the motor to max, we're going to pay more. That's all it's showing. So this is the number you got, though?
Gotcha, yeah. That's
Nice.
what
Okay, perfect. Nice. All right, let's put a fork in that.